Okay, for today, we're doing lines and slope, but even more context and even more complicated because our lines and slopes have to be perpendicular or parallel to other lines. Right? So in this one, we don't have that element of make this perpendicular to that. But when you got C of 10, you stuck the 10 in here, and then you ended up with, oh, there it is, 950. And then this is interpret. Interpret means, what did that mean? Well, C stood for cost. So it cost 950 bucks to make how many or not iPads, what are they? Portaboy game systems. 950 bucks to make 10 of them. So cost for 10. Now, if on the test you couldn't figure out what it's about, which is, it's always about the units. Take a look deep, dig deep at the units. If you couldn't figure out that, you can't get the credit just for knowing 950. All right. So how about the 15,000? Did you figure out that you want to put that in here and then solve? And then did you come up with 100 and how much was it? 185. And what is that? Is that the price of cheese in Venezuela? Probably is, actually. Things are super expensive there right now because their inflation has gone crazy. But that's beside the point. 150 bucks. No, it's not dollars. Again, it's all about the units. 150 what? Game Boys. All right. I know, Porta Boys. Anyway, so that's what you could, if you had 15,000 to invest. There are people that do that. Maybe some of you are going to be an entrepreneur someday, and you've got 10,000 bucks and you've invested it all in your product, and that has worked for people before. They've like started something and they just spent 10 grand to get the whole bunch of units, and then they sold like hotcakes, and then they were able to use that money and make more. And all right. So next, what does this mean in the context of the problem? Well, what is X? Let's talk about the units. Is X dollars? No, X is units, or Portaboys in this case. I know. I'll just use Game Boy for the rest of the hour. Okay, so you can't make negative Game Boys. That's the explain the significance of that. Is this problem wouldn't make any sense if you used negatives. That's what greater than or equal to is saying, is got to stay positive. And then C of 0, that's cost of 0? No. Cost of making 0 units, which how could there be a cost if you're not going to make any? Well, again, if you have a factory and you decide, I'm not making any units today, there's still costs of running the factory, called fixed costs. And you have to pay somebody to watch it. You have to make sure that the lights and power are functioning in case you have alarm systems or whatever. So, all right, last thing, the slope. We finally got to slope. And, well, I see it right here. It's 80. But if you just said 80, again, you couldn't get credit on the test. You got to get the context. 80 what? Is that $80? No, it's not $80. That wouldn't be good enough. A slope is a rate. Dollars per what? Yep. And that's just part of it. 80 isn't the total cost. It's $80 per unit or per Game Boy of variable costs. To get that there was other costs, you also have to pay the fixed costs for producing these units. All right, so anyway, just be really careful with the units involved in the problem. All right, so now what are we doing different today? This looks really scary just because it's got variables running all over the place, and they don't tell you a lot of stuff. But do you get if I've got a basically triangle here, if this is going to be a right angle, then the slope of this line and the slope of that line need to be, what was that thing we said earlier? Opposite reciprocals, okay? So if I don't know what M is, would it be fair to say that the other slope is going to be negative 1 over M sub 2? You get what's going on there? They're just saying, I don't know whatever M was, the new slope is going to be negative 1 over, actually, this should be the original slope. That should be M1. My new one, which is M sub 2, will be negative 1 over M sub 1. All right, so it's just Again, in pre-calc, a lot of times we don't use just number examples. We throw variables into it. Somebody interpret this for me. What do you think the variable d implies here? Distance. The distance between a couple points. The distance between this point and this one is d3. Could you find d3 by actually using d1 squared plus d2 squared? Yeah, you could. Right? So that squared plus that squared, and then you have to take the square root of it, would give you this distance. Or you could say this distance squared is this squared plus that squared. Okay. So if you only had variables and you could get it down to just one variable, m, if you had one variable and one big equation, can you solve? I'm going to say that again. If you just had one big equation and one variable, is that enough information to solve? Yes, one variable, one equation. What if you had two variables? If you had two variables, would one equation be enough to be able to solve it? It seems like an easy question, but it stumps a lot of people. Does this have two variables in it? Can I solve it? That's a good question. What do you mean solve? Can I find the distinct solution, the answer? No. Could I get multiple answers? Yes. But until I got more information, I couldn't know which of those multiple answers you really wanted. Now, if I said, oh, by the way, it also has to work in this equation, 2x minus y as c equals 16, then what could you do with this system of equations? You could solve it. And you could do substitution, yep, or you could do elimination where you line them all up in standard form. But unless I have two equations, you can't solve it. But if I have two equations that have two variables, can I solve it? Yes. What do you think you need when you have three variables? Three equations. If you have three separate equations that have three variables involved, then you can solve them. Catching on to the pattern here? In the old days, when you first started solving equations, you would just have one variable. It was always x, pretty much. Or actually, a lot of elementary teachers use n. So, and just have one variable in the one equation. You can solve it, right? But then you move up to having two variables, and that's actually okay. But I can't solve it unless I have another equation. And then now, of course, we're going to move to like you got three variables. Can you solve that? Yes, if I give you three separate equations. All right, eventually, yes. All right, for today, I just wanted to point that out in this context of this question. Can you solve it? If you've got it down to just one variable, you can solve it. You can always solve if there's only one variable. But if there's two variables, you're going to need two equations. All right, moving on. I'm laying groundwork there for later. On this one, if the slope of this thing is 2/3, well, first of all, does it look like the slope is 2/3? Does it look like it rises 2 and runs 3? If I pick a spot that's right exactly on two lattice points, those things are called, do you get that one actually has a slope of what? Slope of rise 2, run 1. So that's the slope on this line, actually. I feel like I'm crazy down here. What's the slope of this line? It's really easy. What's the slope? 2. Okay. Now, it says that the slope is 2/3. Could I find out if that's the reciprocal, opposite reciprocal? Sure, I could. This thing has a slope of 2. Is 2/3 going to be even like related to that? No, that's not the reciprocal of this one. It's not perpendicular then, is it? So one thing I could say for sure is that if I use the slope of 2/3, it would not be perpendicular. All right. What if I say m is 2 and then it's all right so far? Then what would parallel to it be? Parallel to it would have 2. And what would perpendicular to it b, negative 1/2. Now, what if I said it had to go through a certain dot? Like it has to go through that dot and be perpendicular. Well, then haven't I given you a point and a slope? And couldn't you use point slope then? All right. So that point right there, which is at 3, 4, and I want it to be perpendicular to this line. Would you please write me an equation that goes through the point 3, 4 and is perpendicular to this line right here, which has a slope of 2. I'm going to pause for a second while you write me that equation. Perpendicular to this line and going through the point 3, 4. Hint, if you're stuck, use this equation. Pausing. We're back, and we have put a point which was 3, 4. Here's the 3, here's the 4, right? It's easy to make that mistake. That's 4. That's 3, because the x is 3, the y is 4. And the slope, which is supposed to be perpendicular, we already said it was this, so we use negative 1/2 right here. Raise your hand if you had that one right. Awesome. Okay, so I'm going to give you one just a little quicker. If I had an equation like this, I'd like you to find a horizontal line that's perpendicular to this. I want you to think that through for a moment. A horizontal line that's perpendicular to this. Perfectly horizontal. Explain it. A horizontal line has a slope of what? 0. So it, by definition, would not be perpendicular to this, right? That's what you said, right? All right, you're right. Good. Yeah, it's impossible. All right. What if I said a vertical line? Do vertical lines exist? Yes. Do they have a slope? If they were going to have a slope, you could say it's infinity, at least to kind of think about it. It's like straight up and down, right? It's infinitely strong slope. Okay, so then if I'm telling you vertical or horizontal line, I'm like forcing you to use a certain slope for that, right? What if I said, okay, you can use any slope as long as you make me a line that's perpendicular and has the same x-intercept. Ooh, that sounds like pre-calc. Perpendicular to this and has the same x-intercept. Oh, complicated. Maybe it's not that complicated. All right, perpendicular to this, but has the same x-intercept. If I just said perpendicular to this, it would have been way too easy, right? Not your pre-calc tests aren't that easy. Okay, so some people are stuck on that whole x-intercept thing. Finish this answer for me. The x-intercept is where what? Where y equals 0. So if you set this equal to 0, could you solve it down and figure out what the x-intercept was? You could. And then at that moment, wouldn't you have a point? And then if you have a point, you also have the slope, and it shouldn't be that hard from there. Okay, I'm going to pause for a second here while you figure out a line perpendicular to this with the same x-intercept. Okay, 0 equals negative 2/3 x plus, I'm multiplying this out now, distributing that, 14/3. Then, oh, this is such a pain because it's got this fraction in it. How do you clear fractions? How many of you realize you should multiply by 3? That would have been smart. Because it makes your life so much easier if you just multiply everything by 3. You might be thinking, can you do that with a 0 over there? Yup, you can. So I multiplied everything by 3, and it still says 0 equals. And this one's going to be, 3's cancel, negative 2x, plus those cancel, 14. Now is it going to be easier to solve? Oh yeah, a lot easier to solve. I know, there's other ways you can do it, absolutely. But I want you to be thinking, I want you to be looking for clear the fractions, clear the fractions. That's like one of the mantras that I want you to have. All right, so now, I know, in the end, you could have got this fraction another way. But final answer, I'm going to subtract 14 from both sides, and then divide by negative 2. I tried to do 2 steps at once. Don't do that, Mr. Server. And x equals 7. Raise your hand if you had x equals 7. Okay, cool. So then, what is that spot? It took a long time to find the x-intercept. If it's the x-intercept, y equals 0, right? So then this point is 7, comma 0. Now, it took a lot of time, but I got a point, and I know the slope, and I can use point slope. What's the slope? Should I just use negative 2/3? Of course not. What should I use? Positive 3 over 2. And so if my slope is going to be positive 3 over 2, now it should be easy peasy. Y minus the y of this, which is 0. So y minus 0 is just y, isn't it? Equals x, which is 3 over 2. Sorry, m times x minus the x. And there you go. Isn't that weird? Has the same exact x minus 7 thing in it.
Is that normal, or will it be just...
It's irrelevant, because the problem I just did with you is never going to be done again. But you'll have to think up, maybe it'll be this time, oh, I want the y-intercepts to be the same, or I want to make that just always do it that way, and you'll be fine. Yes?
Wait, if it goes through... Okay, so wait, oh wait, never mind.
You're struggling with something, I can tell. What's bothering you?
No, I multiply it out.
Okay, and you can multiply it out, and that's okay. All right, would you agree that it goes through the 0.70? If I put in 7, do I get 0? Yeah, so that goes through the 0.70. Does this one go through the 0.70? If I put in 7, do I get 0? Oh, yes, it does. Okay, cool. So they both go through the same point. And is that point the x-intercept? Yeah, because y equals 0. It must be. All right, cool. All right, so this is part of your homework, and it's different, and it can be a little bit confusing. If you thought this was a point, you'd be like, okay, you gave me 1 point. How am I supposed to know where the slope between 2 points is if you only give me 1 point? Well, that's not a point. It's a kind of, read the question. Read the question, read the directions. And right here, it would be nice if this little dude wasn't riding a surfboard. It's just a picture. But if I had a graph of x to the third right here, you get it would look something like that. What if I said, what's the slope of that? Do you remember how we'd need a couple points? We can't just say, oh, the slope of that is 0 or 1 or if you take the slope in that spot, you know exactly what the slope is. It's going through those 2 points. What if you take the slope between here and here? Then you just go through those 2 points. The thing you might not know is what you're finding is the average slope between those 2 points. See, on a normal straight line, if I give you 2 points that are on this line, I say, oh, we'll use this point and this point. Well, then there's only one slope. It's just the slope that goes through there. But what if you had something curvy going through there like that? Then what you found is the average slope from here to here, whereas sometimes it was steep, sometimes it was the opposite of steep, and it all averaged up to that slope. Okay, so one more time. Let's say I had a function that looks like this, and I said, what's the slope between here and here? Well, duh, it's just you go through those 2 points. There's only one slope. But what you're really finding is the average slope of all the slopes that you could have figured out that go between those 2 points. So if I say, what's the slope from here to here? It is really not just the slope from that point to that point. It's the average slope of this function between here and here. It's the average slope. Like, it averages in this one where it would have went like that, and this one where it would have went like that, and maybe from here to here where it would have went like that. It averages the slopes. Okay? All right. So when it says, back to this one, it wants, this is not a point. It's an interval. So let's look at that picture again. Would you please make this little sketch just like that? Just make a little sketch like that. And what it's asking for is the interval between -1, which is there, and 2, which is there. And it wants the average rate of change, also known as the slope, of the function over the specified interval. Well, hint, what they really are giving you is 2 points. -1 comma something and 2 comma something. What would it be? -1 comma, you stick it in the function and you get what? -1. And what's the other point? You stick it in the function, you put the 2 in there, what do you get? So it's really the slope that you'd find between these 2 points. That point and that point. You get what just happened there? They gave you the x values of 2 points. You find out what the y values are, and then you'll have 2 normal points. Can you find the slope between 2 normal points? Sure you can. So this is how you make normal math into complicated math. You ask the question in a funny way. Really all it is saying, find a couple points for me with x value this and x value that. And I know it's a 1 comma something and 5 comma something. And you find the slope between those two. All right, for this one, you're finding the slope between 1, and then what if you put in a 1? What do you get? 1. And then when you put in the 5 for this one, you put 5 in for x, and you get 1/5. I got 2 points. Now it's easy to find the slope. All right, you need to continue that process for the next 2, this one and this one. So we're doing the first 4 problems in this assignment. And remember, we're going to grade 2 assignments in one day tomorrow, just to get. It'll be faster because you'll already change papers, and I can get 2 grades in the grade book. This one, I want you to do 1 problem like this. It's a lot like the one we practiced before, except, wait a minute, what shape is that? It's not just a straight line anymore. It's a what? It's a curve. Okay. And it's still, what's the context? Is it still about making porta boys? No, this is about temperature over time. And if you made a sketch, I'm a firm believer of this. Anytime you make a sketch, it's so much easier to understand it. If this is about temperature and time, does it make sense more now that you see the picture? Does temperature go up over time, like in a day, and then back down again? Yeah, see, when you get a sketch, it's no big deal. So that's my advice to you on the test, too, is if you're just looking at some equation and you're like, I don't know what's going on, make a sketch of it, which you can always do with your XY chart if you have to. And you get a sketch of it, and you're like, oh, I see, there's asymptotes there, or I see it's going up and then down. All right. And what if they ask you for a slope? Well, they have to give you a couple points. Maybe you'll ask you to use this x, and then you'll have to figure out, oh, I got 2 points then. I figure out those 2 points, I can figure out the slope. All right. So this one is assigned. And then we're going to make it much more sparse. Cut out these. And this is about finding ones that are parallel. This is just a big, long reminder of how to do parallel. I think you already know how to find parallel slopes. Don't stress about the direction. It's pretty easy. Make me something parallel to this that goes through that. Parallel to this goes through that. And then we'll do these 2 and take a wild guess what the difference is here. Perpendicular ones. Find a couple ones that are perpendicular to this. And then this might mess you out with you a little bit. But hopefully I've given you enough help to figure out what's going on there. We want to be perpendicular on this page. Okay, on to this one. These are good challenge questions, but they can be a little much, so we're going to just do one of them. You can cross this one off. And we're going to skip this very last one. Okay? Bottom line, I've cut it down to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Where was the beginning? It's 11. Okay. 11 questions, which is a lot better than the alternative. So, 2 assignments to be graded tomorrow. Be ready. That's all I got for you for today.